So we are going to take a look at this mixed circuit and figure out how to find the current and electric potential values. Every time you see a circuit, you want to figure out which direction the current is going. And you remember, it always comes out of the positive end of the battery. So it's going to come up, around, it's going to get to this junction, split two ways. So if we're looking at the current, we can see that all of the current through the battery is going to have to go through R1 because there's nowhere for it to split. So that tells me that the current in R1 is going to be the same as the current through the battery. So it's going to be 0.4 amps. Then I'm going to take a look at the junction. So I've got 0.4 amps coming into the junction. That means I have to have 0.4 amps coming out of the junction along those two lines. I can see that 0.22 amps comes along this way. So if I know 0.4 comes in, 0.22 goes that way, I can figure out how much is left over that's going to go down this line. So here I have filled in our table the current values for R1 and R2. I found R2 by doing the subtraction. Remember, 0.4 amps comes into the junction, 0.22 goes this way, so that tells me there's 0.18 left to go down this branch of the circuit. Next, I'm going to take a look at the green loop that is drawn. That's going to help me find the voltage, or the electric potential, through R2. So remember, the rule is when we go around a loop, all of the electric potential that we pick up at the battery has to be dropped off as we go through the different loads. So here I am picking up 3 volts at the battery. That means as I go around my loop, I have to drop off 3 volts. You can see that I'm dropping off 1.4 volts at R1, so you can figure out how many volts you'll have left to drop at R2. So here you can see I figured out 3 volts gets picked up. I lose 1.4, so that leaves me with 1.6 left to lose at R2. Once I've got that figured out, I'm going to take a look at R2 and R3. And I'm going to notice that those two elements there are in parallel. And if you remember your rule for parallel, it says that the voltages or the electric potentials are the same. So that means however many volts are in R2, we will have the same number of volts in R3. So that one's pretty easy. So here I have my completed table. All I did was I said, well, I knew there's 1.6 volts in R2, so that means there has to be the same number that go through R3.